Today we are going to take a tour of the periodic table. The periodic table is truly a remarkable reference, one that you appreciate more and more the more chemistry that you learn. I highly suggest you get your periodic table out because I'm going to have you mark some things on this periodic table as we go through today's lesson. First thing, when you look at one of the boxes on the periodic table, there's plenty of information in those boxes. I want to talk about what each piece of information is. Very simple to start with. We have the symbol for that element. It's either one capital letter or a capital letter and a lowercase letter. I'm very picky about that. Make sure that you write your symbols properly. Underneath the symbol, you're going to have the name of the element on most periodic tables. Then we'll have the atomic number. That's the whole number in the box. On ours, it happens to be in the upper left. It could be a variety of different places depending on the periodic table. The decimal number in any box on the periodic table is the average atomic mass. Now, the periodic table gives you other things as well, especially ours. The color of the symbol is going to represent what state that element is at 0 degrees Celsius or 273 Kelvin. If it's a black symbol, it's a solid. Blue means liquid. Red means gas, and gray means we don't know yet. We don't know enough about that element yet. Our periodic table also gives us another little piece of information. It tells us what class of element it fits into. The carbon atom here happens to fit in the classification of other nonmetals. Now we're going to talk about rows and columns on the periodic table. Rows are called periods. Columns are called groups. The way I remembered that when I was in your position was P and R are closer together in the alphabet, and G and C are closer together in the alphabet. Period with row, group with column. That's how I always remembered it. There's going to be different numbers of elements in each period, and that's because what a period actually represents is how many energy levels, how many orbitals an atom can have. Any element in the first period on the periodic table, hydrogen and helium, they only have one energy level, one electron cloud to put electrons. In the second period, there's two energy levels, two electron clouds for electrons to occupy. And then it goes up from there. So 3 energy levels, 4 energy levels, 5 energy levels, 6 energy levels, 7 energy levels. So the periods actually represent how big the atom is, how many energy levels there are. A group is a column. What's special about a column is the elements in a column have similar chemical and physical properties. We will talk about the reason why they have similar chemical and physical properties in the future. Now, there are 18 groups in the main body of the periodic table. We always take the lanthanides and actinides and put those below the main periodic table. The reason for that being, if we included them into the periodic table would be huge. It doesn't fit well on a poster. It doesn't go well in a book. We don't use those elements in everyday life very often. So we take that block, the lanthanides and actinides, and we just remove them from the periodic table. Makes it a lot easier to put on a chart in your room. So the periods, once again, represent elements that have the same number of energy levels, same number of places for electrons to occupy, and groups occupy elements that have similar properties. So a couple questions before we go on, so you can check your understanding of what we've learned so far. So which element is in the same period as sulfur? Here are your options here. And which element is in the same group as antimony? Here are your option choices here. Pause the video, try to answer those questions, check for understanding. All right, here's another couple questions for you to check your understanding so far. Got a little skeleton periodic table here. What is the atomic number of element D? Given some information here, you should be able to determine what the atomic number of element D would be. All right, and which element has the most similar properties to element E? So based on what we've talked about, we should be able to answer that question. So pause the video, try those questions out as well. So elements in the same period have the same number of orbitals or electron clouds around the nucleus. Elements in the same group have similar chemical and physical properties. The periodic table can also be divided into classes. Elements on the left side of the periodic table are metals, with one exception we'll talk about later. But everything on the left side of the periodic table are metals. Most elements on the periodic table are metals. Then we have a group called the metalloids that separate the metals from the nonmetals. The nonmetals are on the right side of the periodic table. The metalloids, as you'll see, have properties between metals and nonmetals. One thing I'd like you to put on your periodic table is actually a little staircase that separates the metals from everything else. You may have seen this on other periodic tables, like on a poster. You can take a marker, a pen, or something, and you can draw this staircase into your periodic table so you can more easily find where those metalloids are, the boundary between metals and nonmetals. So let's talk about each one of these classifications of elements. Metals are almost always solid at 0 degrees Celsius. The one exception is mercury. Metals tend to lose electrons when they react. Remember, metals are good conductors of electricity, good conductors of heat as well. That's because their electrons move so freely through those materials. Metals are malleable and ductile. I can take this paper clip, can easily bend it into a new shape. That's malleable. Ductile means I can draw it into wires. So metals are very easily formed into sheets or wires. As you go from the left to the right on the periodic table, you go from very reactive metals. So the elements in that first group are very reactive, and to more non-reactive metals. So group 1, very reactive. Group 2, kind of reactive. You get all the way to the right. As you move through the transition metals, you get to metals that are very unreactive, like gold and silver and platinum, precious metals that are worth a lot of money. They're precious because they don't react with anything. Nonmetals are on the right side of the periodic table. If you look at the symbols and the colors of the symbols on the periodic table, you can find them as solids, liquids, or gases. When they react, they're going to gain electrons instead of lose them. They are terrible conductors of heat and electricity. They are insulators. If they are in the solid form, like graphite from a pencil, we all know, a bunch of carbon atoms, they're very brittle. Okay, they're not very shiny. They don't have a luster like a metal does. And when you look at the nonmetals, the most reactive nonmetals are actually in group 7. Group 8, the last column on the periodic table, called the noble gases, they are totally unreactive or inert. So the group of elements between the metals and the nonmetals are called the metalloids. They will have properties between those of metals and nonmetals. They usually have the physical properties of metals, but the chemical properties of nonmetals. Some of them are shiny and have luster. Others of them are very dull. The most common uses for these elements is as semiconductors, because their electrical conductivity will change based on environmental conditions. So they have a lot of specific uses out in the real world. All right, that was a lot of information. So until next time,